Welcome back to Bitcoin and Beyond. Today we have Orkun from Citrea talking about building Bitcoin's first ZK rollup. Looking forward to learning about the practice and the implementation of ZK in Bitcoin and what you guys are building at Citrea. Welcome in, Orkun, and glad to have you.
Hey, Andy. Hey, Robbie. Thank you for having me today. I'm excited to present what we have been cooking so far and how it actually changed Bitcoin's future. I can just directly start. I'm one of four co-creators of Citrea. We are building Bitcoin's first ZK rollup. We have been working on this project before even all the hype and the BitVM paper came out around a year ago. Initially designed this as a different kind of rollup, but right now we are building Bitcoin's first ZK rollup. So let's get it started. What is a rollup? The basic definition, it confused all the people, especially on the Bitcoin side of the things. People don't get used to this kind of definitions, so they often skip. And in Ethereum, it is also something very confusing. So the rollup, by definition, is a blockchain that uses another blockchain as the data availability and consensus layer. Okay, where does the settlement fits in, or the bridging, or the ZK, or the optimistic, or the execution layer? It doesn't matter. It is not a part of the definition. So the definition is very clear. If you have a blockchain, and if you are using another blockchain to have your data available and so sort all this data so you have the consensus, then you are a rollup. It doesn't matter whether you are a ZK or optimistic or EVM or Solana VM. So essentially, why you should build a rollup on Bitcoin? Let's get into that. And Bitcoin is the most secure and censorship-resistant block space running over a decade, and it has a proven record on having a secure and decentralized network. But it has limits, right? It has limitations on block size, it has limitations on script capabilities. So what you can do with Bitcoin beyond simple payments is extremely limited today. And this has a reason, and I totally respect that reason. But some people like us want to do more with their BTC, want to do more with Bitcoin block space security. So the thing is the modularity. When you get modular, you have this customizability. What this means is now if you have building a rollup, then you can customize that rollup as much as you can. You can do payment rollup, you can do gaming rollup, you can do EVM rollup or Solana VM rollup, because now you have this flexibility to actually customize your stack. You are not dependent on Bitcoin, but you are building your own stack. And as you are building your own stack, you can also do some optimizations. For example, we will talk in a bit about ZKproofs, state diffs, general purpose compression. These are new things that actually can scale blockchains without actually changing the core blockchain itself. So that's the one aspect. And the most important thing is Bitcoin is secure, and all the layers built on top of it must be secure. So if you are building a simple sidechain, you cannot get this security by default, because you are now trusting another layer's consensus or proof of work or nodes or data availability to actually store your data, publish your data, or do not transact with invalid blocks and other stuff. So the security is the most important thing in Bitcoin, and a layer should inherit that security. And building a rollup is the only way to actually getting that security. If you are not building channels like Lightning or Mercury, which is still limited with Bitcoin's functionality. And the other thing is the interoperability issue. So you can get some kind of Bitcoin security with, let's say, merge mining, right? You can build merge mine sidechains, which exist over a decade still, but you cannot get interoperability. You cannot bridge BTC from main chain to sidechain, because hash power cannot actually custody anything or cannot transact anything. It can only secure the sidechain's consensus. So you still need additional federation or some other thing to bridge the BTC from one chain to another sidechain. So we are building Rollup to solve all these issues. We are getting full Bitcoin security. We have this most trust minimized two-way peg, which I will talk in the slides. That's the main thing that I will talk today. So let's get it started. In order to build a Rollup, you have to,
Orkun, can I ask you a quick question?
Yeah, for sure.
So you had a very clear definition of a rollup, and then you mentioned some of the differences between a rollup and a sidechain. Could you just articulate what is the definition of a sidechain? How is it different from a rollup?
Mm-hmm. Yeah, so the rollup has a strict definition, but sidechain doesn't have a strict definition. So in my mind, I have several categories. Like the rollup, a blockchain that uses another blockchain as the data availability layer. A channel that works in peer-to-peer manner, so you don't trust anyone else, but that's limited. There's no global state. Plasma, which can build with UTXO with off-chain data, but you still gain some limitations when you try to add programmability. And the rest of the stack is sidechains. You can build proof-of-work sidechains with merge mining. You can build proof-of-stake sidechains with Bitcoin stake, or you can be a totally independent chain, but you can anchor some data to Bitcoin for finality, but it's still a sidechain. So there is no clear definition. But in my definition, it cannot ever get unilateral exit. So if it cannot get ever unilateral exit, I will say it's a sidechain. So Rollups today on Bitcoin doesn't have unilateral exit because there is no opcode. But in the long run, if there is an opcode, you can get unilateral exit. If there is a plasma for opcode, then you can get. And with sidechains, you cannot, because sidechain is another chain that has its own security. So you have to trust that chain first. Then you have to trust the peg mechanism, the bridge mechanism. That will be my definition.
Cool. And just follow up there for the community who's a little less technical, what is an opcode? And then similarly for those who are a bit more technical, is there a difference in opcodes for Bitcoin versus Ethereum?
Yeah. So in Ethereum, you have these opcodes, but these opcodes is not limited. So you can actually you are writing Solidity and you are writing some smart contract, but your guess is measured by these opcodes. And it is Turing complete, so you can actually build everything with that opcodes. In Bitcoin, we have very similar opcodes with Ethereum, but the main thing is the number of these opcodes and what they can do is extremely limited. So there is no multiplication opcode in Bitcoin script. So you cannot multiply two numbers. Or there is no concatenation opcode in script. So you cannot actually concat two string and build a Merkle tree, for example. So that's the main definition. While building a Bitcoin script, you have this set of opcodes and you have this stack which your inputs are ordered and the outputs will be ordered. And you are just getting some item from stack, applying some opcode and putting into stack again. So you are doing that to actually create Bitcoin scripts, and it is not Turing complete because you cannot do for loops, you cannot do multiplication, you cannot do division, and you cannot do modulus. That's why you cannot do, let's say, ZKproof verification as single scripts or something like that. So let's continue. How you can actually use Bitcoin as your data availability layer to actually become a rollup. So it's a bit historical definition. So initially, in the initial days of Bitcoin, we have this OP return opcode. We still have it. So what OP return provides is you can append 8 bytes of data next to OP return, and it will be broadcasted across networks. So you can actually use this to make a data available. But 8 bytes is extremely small. Just an hash is 32 bytes, so you can fit two hashes, let's say, and nothing more. So that was the issue. And later, there was a software called SegWit. And what SegWit did is basically increase the block size from 1 megabyte to 4 megabyte. But Bitcoin doesn't get hard fork, unlike Ethereum. It gets soft fork. So in order to Bitcoin older nodes to be compatible with SegWit, what they did is they separated the block with the witness. So now you have 1 megabyte of actual block transaction data and 3 megabytes of witness data. And this witness data doesn't have to get broadcasted to the older nodes, or they can ignore the witness data. That's why Bitcoin soft forks are backwards compatible. And with SegWit, we had this 4 megabytes of blocks, but the script size was still limited with 10 kilobytes. So you cannot actually embed data more than 10 kilobytes. And after that, the next soft fork and the latest soft fork was the Taproot soft fork, which allowed 4 megabytes of scripts, equal to the block size. So this means that if you can now work with a miner, you can actually mine a block, which includes a single transaction that has the whole block space, just like Taproot wizards inscribe their wizard image. So that actually, some people think about it, and Casey Rodarmor, a former Bitcoin developer, come up with a protocol called Ordinals. Ordinals is actually a meta protocol that indexes some satoshis, individual satoshis, and gives some numbers, but the inscriptions is the name of the concept. And what the inscription is, he find a way to put arbitrary data in Bitcoin script up to 4 megabytes. So in the right, you are seeing a Bitcoin script. And what he did is simply put op false, then op if, so that the rest of the branches never get executed in the full nodes, but they are still available in the script. So you can actually publish data into Bitcoin, but that data can be arbitrary because it doesn't get executed ever. in the blockchain. So what he did is he just pushed some arbitrary byte data and broadcasted it to the network. So now you can actually use Bitcoin as a data available to you.
And in the previous example, before we had SegWit, Taproot, and Ordinals, you mentioned that the opcodes on Bitcoin were extremely limited. We couldn't do multiplication. We couldn't do for loops. So we couldn't do arbitrary data. How did that change? Why are we able to do arbitrary data now, but we weren't even able to do multiplication in the past?
We still don't have multiplication or division. The Taproot SegWit is not about that, but they're about increasing the block size and the script size. So in OP return, you can put arbitrary data, but you can put up to 8 bytes, which is way smaller than a regular ZKproof, for example, the smallest ZKproof. You can only put 2 hashes. But with Taproot, we still cannot do all the ZKP thing and like multiplication and other thing, but you can put 4 megabytes of arbitrary data, which is like a huge amount of data. If you just, let's say, put it hash, you can put like thousands of hash into a single block using that mechanism.
Okay, so it's not a limitation on the size, but more so on the complexity of computation that we can do in a Bitcoin script.
Actually, the reverse. The complexity is the same. The opcodes are the same, but the size is increased. Before that, you could only do 80 bytes. Now you can do 4 megabytes. But what you can inscribe is just arbitrary, but the operations didn't change. You still cannot do multiplication or division or other stuff.
And when people are thinking about using Bitcoin as a data availability layer, what is the core trade-off? Like, what is the actual trade-off of cost versus using like one of these modular DA layers if they're compatible with Bitcoin rollups? Like what is the actual trade-off here, and how realistic is it to use Bitcoin as a data availability layer for one rollup or for 1,000 rollups?
So if you use Celestia, let's say, or Avail as your data availability layer, then you are not a Bitcoin rollup, right? The definition of the rollup was you should use another blockchain as your data availability layer. So if you use Celestia, then you are a Celestia rollup, but maybe Bitcoin Validium or you can be, or Bitcoin Optimum you can be. So you have to use Bitcoin data if you want to get full Bitcoin security. If you don't care about full Bitcoin security, but if you want to, let's say, only get some bridging, you can use Celestia as a data availability layer or Avail as a data availability layer, and you can get this bridging. But in that case, you cannot get the full Bitcoin security. Because, for example, in Citrea, we are using Bitcoin as a data availability layer, and all our full nodes look every single Bitcoin transaction and extract the arbitrary data from it. And if it is a ZKproof, then it verifies it, which means, and it also takes that data and applies to the state, which means that if there is data on Bitcoin and the proof is on Bitcoin, then that's your canonical chain. But if you use Celestia or Avail, you have to trust that chain to make the data available, to actually not reorder the chain, not reorg the chain. So you get all the security depend on that chain. But if you are building a Bitcoin rollup, you should use Bitcoin. You must use Bitcoin as your data availability layer.
So from your perspective, is it an ideological alignment posturing to use Bitcoin as a data availability with a desire for high security versus users and developers wanting to build on something that is cheaper and more scalable? Like, how are you thinking about this from your perspective?
I think it's case by case. You know, if I'm building if I want to build a high speed gaming chain, I wouldn't use Bitcoin as a DA layer because you don't need that much Bitcoin security and you don't need that expensive transactions. But if I'm building a Bitcoin-backed loan protocol, let's say an Aave fork or Compound fork, I want my Bitcoin or USDT to be secured as Bitcoin and not with some other chain. I think that's where trade-offs began. If you want to do high value transactions, you should do it on Bitcoin chain. But if you want to do, let's say, low value transactions or don't care about the security that much or want high speed or low cost, you should use other layers as a DA layer to make it actually make user experience better.
Cool. And then just last thing here, I don't want to get too caught up, but it's important, I think, is the security practice of using like Celestia or Avail in this case, in these examples, more secure than a side chain with a small number of nodes that is running like a delegated proof of stake consensus? Or is it's kind of dependent on the decentralization of that side chain? But how are you thinking about the difference between chains which use like a modular DA layer versus side chains which are separate?
Yeah, I believe if you are building a volume, let's say you are building Citrea, but you want to use DA layer for like, you want to use another layer as your DA layer, I think it is much secure than side chains, because you still have this DK verification on the main chain, so it cannot actually steal the money, but maybe freeze the money. It is definitely secure than most of the side chains today. Only 1 or 2 side chain can be secure than that construction. So, okay, we figured out how to embed data, and so what should we embed? And now we have this distinction between the rollup types. So we have 3 different rollup types, very broadly. Pessimistic rollups, I think there is no rollup like that, but some SDKs are working towards it. The pessimistic rollups just embed full block data into the underlying chain and move on. And optimistic rollups, like most of us know, they embed full transaction data and a state root. So after a week, if no one challenges that state root, it becomes valid and there can be settlement if the chain prefers. But what they put as a data, the huge amount of data is still full transactional data. And on ZKRollups, you have 2 options. One is full transactional data plus the proof, or you can use state differences plus the proof. So what state difference mean and full transactional data mean is, if you have a rollup, then we call it if you have a block, we call it full transactional data. If you put all the block into the underlying chain, this is full transactional data. But in ZK rollups, I think it was first Starknet or ZK Sync, I cannot remember. They use this technique called state diffs, which actually you input the block into ZK circuit, and the output, you say, instead of giving full transactional data, you only need the difference between the initial state and the latest state. Because you just want the data. You don't care if the proof already asserts that the execution is correct. You don't need the full data. You only need the difference. So if you use state difference and proof, it makes the data much more scalable. Because if you are using the same Uniswap pool, let's say, until the proof is generated, if everyone uses the same Uniswap pool, only balance, the state diff will be only the balance change between the first Uniswap transaction and the last Uniswap transaction. But if you use full transactional data, you have to embed all these transactions into the underlying chain, which makes the data expensive. So we are using state diffs plus proof construction to use Bitcoin very, very efficiently, because Bitcoin DA is already limited and it can also fit no more than 4 megabytes. So we have to use it very effectively. And we choose to use the state differences plus proof mechanism, because we are waiting proof to be generated, and meanwhile people do transactions and I send money to everywhere, and only my difference between the initial balance and the latest balance is recorded on the Bitcoin, which makes the data usage very, very efficient. So, okay, we cracked it. We built a rollup. We sent our proof and state diffs to the Bitcoin, and now we built a rollup. But on Bitcoin, the 2 things is, I think, the most important part. The one is the most secure and censorship resistance block space. Now we have it because we are using Bitcoin as our data availability and consensus layer. The other thing is the BTC asset. It is over 1 trillion sitting in the Bitcoin main chain, doing nothing than payments. But in order to use this BTC on the rollup, you have to have some secure bridging or settlement solution to people to deposit BTC from the main chain and mint on the L2 and burn on the L2 and get back on the L1. So far landscape was like on the left side. There is custodial Bitcoin bridges, we know that, WBTC on Ethereum. And there are federated threshold bridges like Rootstock BTC and Liquid BTC, the OG Bitcoin sidechains. And now there are 3rd generation of this BTC bridges, crypto economic security bridges like SBTC and TBTC. SBTC on Stacks, TBTC on Ethereum. So how they work is federated threshold is you just trust a majority of a federation or of a committee. Let's say there's 10 people and you are trusting that 7 of them are honest. In crypto economic security, you are still trusting a federation, but that people actually stakes some other assets. It cannot be Bitcoin. In most cases, it is some other assets. Let's say in Stack's case, they stake STX, and I think in TBTC it is the T token. I'm not sure. And they stake that asset, and if they steal the money, then you can slash that asset. But there are some issues with that because you have to have some oracle to actually like secure the peg, and if the stake token is too volatile, then you can bridge can be stolen and that people can leave with a price. So these are like great construction back then, but right now we have better constructions. So the most important thing is the native settlement that you can get. And right now there are two options to actually verify ZKproofs on Bitcoin. One is not possible today because you have to verify the ZKproof in Bitcoin script. But like I said in the beginning, there is no Turing completeness on the Bitcoin script and the block size is limited. So you cannot actually verify ZKproof in a single script in Bitcoin. So it is not possible if we can not get any opcode, let's say op ZKP verifier, right? If we have this opcode, we can easily verify, but there is no opcode that can provide this functionality. So given this idea, a researcher called Robin Linas last year started ideating some things, how we can verify ZKproofs on Bitcoin. And he actually came up with the idea of BitVM. The initial days of BitVM was like a different protocol. It now like pivoted more towards a different thing, but eventually what it provides is you can optimistically verify ZKproofs. So as long as everyone agree with the ZKproof, you don't have to do anything. But if someone disagrees with the ZKproof, they can go on chain and put an alert to saying that this ZKproof is incorrect. And in a couple of transactions, you can actually assert that the ZKproof is incorrect or not. So instead of verifying in every single time, you just make it optimistic because it saves you from a lot of cost because these fraud-proof transactions are too big and the transaction costs are too high. So that's the core idea behind BitVM. And then we introduced Clementine, our BitVM-based two-way peg, also known as bridge program. So I put 1.5 there because right now there are two variants of BitVM. One is BitVM 1 and the one is BitVM 2. BitVM 1 uses a closed set of people with a RISC-V-like architecture. And BitVM 2 has this permissionless idea with a ZKP verifier. And in Clementine, what we are building is somewhere in between. We have this closed set of participants, but we are not building upon a RISC-V verifier architecture, but a ZK verifier architecture. So we have, with Clementine, now the core idea is you can get optimistic settlement for ZKRollups. This is extremely unique and probably a bit complicated because in Ethereum, you don't need that. You can just verify ZKproof. In some other chains, you can just verify ZKproof. But in Bitcoin, we try to crack the best way of building a ZKRollup. And we come up with this optimistically settled ZKRollup idea. And Clementine provides the optimistic settlement part of this product. And the core idea is aggregate the proofs from Bitcoin. Because you use Bitcoin as the A layer, all the proofs are available. You just aggregate the Bitcoin proofs from Bitcoin to settle less frequently because you cannot settle in every single block. It will be like expensive. So we are just inscribing the data and wait a little bit. And then once all the batch is inscribed, we just aggregate these proofs. And eventually we have a single proof representing all the Citrea state. And then there is this operator person who front covers all the withdrawal that is requested from the rollup. And eventually operator says, okay, I aggregated these proofs. These are all the withdrawals. I did all the withdrawals. And this is the whole ZK proof saying my statement. And there is this closed set of participants. Let's say there are 10 participants. And they verify this ZK proof. And if everyone verify, they just sign a transaction and move on. But if only one of them thinks that the ZK proof is incorrect, they can go on chain and challenge the operator. So that the operator, if the operator lies, it gets slashed and kicked out. So your money is still secure. And the trust assumption of this mechanism is we call trust minimized because now you have this one of an assumption. As long as one person in this N people is honest, then your money is secure. And remember, previously in crypto economic security, in federation threshold, you have this majority assumption. As long as majority of 10 people is honest, then your money is secure. So you have to trust multiple people. You have to trust 7 people, 8 people of 10. But in here, if you know only one people of the participant, only one person in the participants, then you are secure and your money is secure.
So, Orkun, I find this this one of n fraud proof mechanism fascinating. Like, how does the blockchain operators, how do the miners, how does everyone know? Let's say let's say the three of us are verifiers, and let's say Orkun, let's say you're telling the truth and Andy and I are lying, and there's two of us, but there's only one of you. How does the blockchain know that you're telling the truth?
Yeah. So the BT is with BitVM is what they do is they get a snark verified in Bitcoin script, but it is, let's say, more than 100 megabytes. So you cannot put it into a single script. And they divided this script into multiple chunks. So eventually you can do, let's say, bisection, or you can just reveal all the intermediate steps and someone can directly challenge the intermediate step. So what happens is, if you actually I'm the truth, I'm the correct one, but you say, okay, your ZK proof is wrong, right? You go on chain and say to me that execute this branch, execute this chunk of script. And I actually execute it. And eventually, if the script returns true, which means that I am the truth and you are the liar, so your stake is slashed. That's why it's trust minimized. If you don't get on-chain evaluation, you cannot do trust minimization because it's always honest majority. But with this ZK proof, ZK verifier divided into multiple scripts, we can actually execute some selected part of the scripts to determine who is correct or who is not, without going through all the verification steps of the huge script.
And what if we kept playing this game? Like, what if we kept kind of like going down deeper and deeper and kind of like checking, right? We would ultimately kind of like refine the data that we're checking. Wouldn't that take a very long time?
Yeah. Yeah. So in the BitVM one, it was 40 transactions. So in BitVM one, we have, in the worst case, you can challenge me until 40 transactions, and eventually you will be wrong. So your all transaction fees and all the stake is gone. But it can actually freeze the breach for months, let's say, because it will take 40 transactions. But with BitVM2, they find a concept that I call this intermediary steps. Instead of doing bisection over chunks, they did this intermediate step trick. So it is only just one transaction. So if you give one transaction a week, similar to Ethereum optimistic rollup, then you can only challenge me once. You say that reveal that step, and I reveal, and if I'm correct, you are just kicked out. If you point out another script, it's already incorrect, so you are already kicked out. So you can actually freeze the breach only for 1 week, which is very similar with Ethereum optimistic rollups.
Got it. And in Ethereum rollups, the 7-day challenge period is still quite arbitrary. What is the rationale behind the 7-day kind of like standard that we've landed on? Could we make it shorter? If so, how do we do that?
Yeah, I think it's about the base layers, how long the base layer can actually censor you, like any party. So in Ethereum, researchers did some research and agreed on 7 days is the sweet spot for base layer to because they did some economic analysis. If you get the, let's say, majority of Ethereum stakes, and if you censor a transaction for 7 days, your stake has to be, let's say, 1 billion. And all the optimistic rollups, let's say, back then was total less than 1 billion. So it was not feasible. So and they picked 7 days. And on Bitcoin, the rationale is very similar. As Bitcoin is with hash rates, it is almost impossible to censor a person for 7 days. You have to have this 51% dishonest majority for 7 days, which costs a lot in an economic sense. So they choose 7 days for single transaction. But on Ethereum, in 7 days, you can do multiple transactions. So there's some different parameters. But I think the BitVM researchers just select 7 days because it's kind of standard for optimistic rollups.
And so in the BitVM 1.0 case, it was 40 transactions. BitVM 2.0, it's only 1 transaction. And so that has shortened the time quite a bit. In this BitVM 1.5 case that you guys have with Clementine, what is Is there a middle ground, or it's still just one transaction for 7 days?
Yes. Okay. We got this one transaction trick from BitVM2, and we kept the permission set of verifiers from BitVM1. So there's no naming like BitVM 1.5, but I just call it while telling about this one to people.
Makes sense.
Yeah.
Cool. Yeah, I was just gonna ask about the top bullet. Is the settlement of proofs, is it kind of done on like a as needed basis with an arbitrary value of time or proofs, or is there like a programmable setting in Clementine which provides like if this then that kind of architecture?
In Clementine, it is 3 weeks fixed. In every 3 weeks, this rollup settles, and that has some things because in Clementine we have this one transaction to challenge, but we have 2 transactions because one is to give the input on chain and the other is to resolve the input on chain. So each takes 1 week, and we give 1 week period to operator to settle all the withdrawals. So eventually we are settling in every 3 weeks. It is fixed. It is not weeks, by the way. It is just some Bitcoin blocks. But if you multiply that with 10 minutes average time, it is 3 weeks.
Yeah. And one of the core pillars in the beginning was around interoperability. By being a rollup was something that you guys value highly. When it comes to having this 3-week proof aggregation window, how do you think about interacting with interoperability providers to ensure that there's not any sort of catastrophic like state reorgs or just general kind of mismatching of states when it comes to interacting with other rollups with different aggregation times or even like sidechains?
Yeah. So the settlement happens in every 3 weeks, but the proof generation and inscription on Bitcoin happens in every 2 or 3 Bitcoin blocks, let's say once in every hour. So we actually put these proofs in Bitcoin more frequently, but we only settle less frequently because the settlement is expensive with BitVM, even with BitVM. So we are just inscribing these proofs on Bitcoin in, let's say, every hour. So other rollups can read the proof from there and execute based on that, or other chains or side chains can read the proof once in every few hours. So they don't have to wait 3 weeks. This 3 weeks is only to have this Bitcoin L1 to Citrea bridge.
So if I'm a separate rollup or a separate interoperability provider, the maximum time that I would be looking to wait for like a confirmation of a state transition would be like 2 or 3 blocks.
Yeah, in 2 or 3 blocks, we prove and put the proof into Bitcoin. And if it depends on your configuration, if you just want to use that data, you can use, or if you want to wait some reorg blocks, you can wait 3 blocks or 4 blocks or 5 blocks, depending on your security config.
And just another follow-up to that interoperability question, and you sort of touched on this by describing the settlement of L1 to the Citrea bridge. Like, what is the difference between inscribing the proofs into the Bitcoin chain and settlement? Like, what, to me, it's like if I inscribe the proof into the chain, that settles the chain onto Bitcoin L1. What's the difference between inscribing the proof and actually settling to Bitcoin?
So in the beginning, I showed this, right? You remember this. This is op false, op if, then the inscription data, then op end if. So in this script, what happens is this branch between op if and op end if is never get executed because it is meaningless. It is just byte data. And once we inscribe the data here, Bitcoin script doesn't understand anything about data. It doesn't even go into that branch. It just skips the branch because it is false. It's not true. So it doesn't have to get in there. So once we inscribe the proof, what we gain is other full nodes can look into Bitcoin and see the proof and verify the proof. So locally, if you are running a full node, you can make sure the state is correct. But Bitcoin still doesn't know that. Bitcoin still doesn't know anything about your rollup, but your full node know because you just looked to Bitcoin, you saw the proof, you verified it, and now you're good. And with settlement, Bitcoin script actually knows that this proof is correct. And then it actually allows movement of the UTXOs between the BitVM and the withdrawal people.
Okay. So that's really cool because it means that correct me if I'm wrong, but it would mean that like that first Genesis block that Satoshi did where he said National Bank of Britain on the brink of collapse, right? That was like the first inscription.
Yes, exactly. He inscribed that first arbitrary data into Bitcoin blockchain, and now we are inscribing ZKproofs into Bitcoin blockchain.
And we're also like making memes of it and trading runes and shitcoins and having a blast.
Yeah, people like shitcoins, and they like BRC20s and runes, which are like a very similar protocol with rollups. Actually, you just inscribe arbitrary data and full nodes read that data and create a meaning of it. Bitcoin doesn't know whether it's a BRC20 or runes. It is just some UTX. So in this sense, it is the same. It is just some ZK proof, but Bitcoin sees that it is just some UTX. So until it gets settled with VM. Okay, and the last slide, Citrea. So if we collect all these pieces together, we have a ZK rollup that uses state diffs, inscribe the proofs and state diffs into Bitcoin, and optimistically settles to enable the most trust minimized and secure bridge. We call this Citrea. So Citrea uses its native token and gas fee token as BTC. The data availability is Bitcoin, and in the future it is Volition. I can touch on this a little bit. And this other is censorship resistance. It's with Bitcoin miners. As we are Rollup, we have access to this Bitcoin data trustlessly. And we will enable this forced transaction mechanism, meaning that if the sequencer censors you, you can just use your transaction to like inscribe the transaction into Bitcoin, and the sequencer has to execute it, because if not, the proof generation will fail and the sequencer will get slashed. So the idea is you get Bitcoin level of censorship resistance. Bitcoin cannot censor you and won't censor you, so the rollup cannot censor you. And the reorg resistance, it is still on Bitcoin because the proofs are inscribed on Bitcoin, and if the chain doesn't reorg, then your chain is also the same. The bridge is Bitcoin settlement via BitVM, Clementine. Execution environment, we are building our own ZK EVM, type 2, fully EVM compatible. And the block times, we are targeting 2 seconds or 3 seconds.
Yeah, so let's dive into the Volition in the future conversation. Yeah. What are you guys thinking here?
Yeah, so the Volition is like a hybrid blockchain mechanism. In blockchains, you have this Merkle tree, we call this state tree. And the root of that tree represents a unique hash of that tree. So in Volitions, what you do is you divide that tree into two. You already have the left branch and right branch, but you divide it into another two. So you call this left branch, let's say, the on-chain data, and you call this right branch with off-chain data. And both of them roots are still available on ZKproof, and the main root also available on ZKproof. But what happens is you only inscribe the state diffs of the left tree, but not right tree. So if you, let's say, want to deploy Uniswap fork, you can deploy on the left tree. So all your transaction is available on Bitcoin, and you have this full Bitcoin security, but you have to pay this DA fees because you are inscribing data into Bitcoin. If you deploy your fork on the right side of the tree, you still get this ZK proven thing. So your proof is still valid. You still get this BTC bridge, but your data is kept off-chain within the sequencer and full node network. So you don't have to pay any DA fees. Only 1 cent, or let's say less than 1 cent. So in this manner, these two Uniswap forks can interact with each other because they're in the same blockchain. They're in the same tree. But one data goes on-chain, one data goes off-chain, and the one is extremely cheap, sub-cent transaction. Other is a bit expensive, but it gets full Bitcoin security. So depending on your usage, if you want to deploy now a gaming application, you can use off-chain data. It is very cheap, very fast, but still gets this BTC and interoperability. If you want to build a like Bitcoin-backed stablecoin application, you can use on-chain data, so your stablecoin is fully on-chain secured, fully Bitcoin secured. A bit expensive, but you still get this interoperability between the gaming application and the stablecoin application.
Yeah, so this enables like multiple use cases from builders, kind of gives you a more diverse ecosystem, basically assessing where your trade-offs are. This might be a silly question, but like, what if I find myself right in the middle? I want both security and I want cheap fees. What do I do?
I think there's no such trade-off exists, right? If you want to get like security, you have to pay for it. And Bitcoin is kind of premium block space. It's not that cheap, and it shouldn't be cheap. because the miners should be incentivized to mine the chain. So it should be actually expensive and block rewards should be high. So if you want to get full Bitcoin security, you have to pay a premium. But you can still get some kind of Bitcoin security with ZKproof, the proof verification, the trust minimization, and interoperability. But you can use off-chain DA. It's slightly reduced security, but it can be extremely cheaper. So I think there is the trade-offs are always there. Even on Ethereum, like the main chain, the Rollups, there are some significant security trade-offs, even though costs are like extremely different. It is not the same level of security. And in here, the other point that I wanted to touch was the data availability part of Bitcoin, right? I said Bitcoin alignment. It's a silly word, but it's actually real bit, because in proof of work, in the long run, you need fees to actually boost the hash rate, right? We had a halvening, and we will have another halvening and another until the fees go to like the zero level, the work level goes to the zero level. So in each halvening, we actually users have to pay more fees to keep miners incentivized, or the Bitcoin price should be double in every halving, or both. So as long as you pay more fees on Bitcoin, you increase the hash rate, you increase the security of the network, and you contribute to like this you fix the long-term security budget issue that people call. So if you are using Bitcoin as a DA layer, which means we are paying thousands of dollars in BTC to miners and keeping them incentivized and to mine the chain and actually get back with more hash rate.
Yeah, I was going to ask about that. Kind of how you guys are, like, how you see Citrea contributing to Bitcoin. It's like bigger than just Citrea Chainway. It's like the broader ecosystem scaling Bitcoin as a whole. It further contributes to its security. Now, on that point, and I know Rob's got something, then we're going to wrap up. Do you see yourself ever having like a Citrea stack where builders can come and build new rollups using Citrea's tech, either like a layer 3 or like a hosting an ecosystem of Citrea rollups outside of just the main chain itself?
Mm-hmm. So Citrea stack is extremely unique. So it is like an early fork of Sovereign SDK. You had Jam last week, I think, in here. It's an early fork of Sovereign SDK. We now like collaborating with more efforts to like merge these chains to get these efforts together. But eventually, it is extremely difficult to adapt to other chains because it is specifically designed for Bitcoin with BitVM. And no other chain has this trade-off. All the EVM chains or Celestia, ZK accounts, and Avail, they don't have this trade-off. We built it specific for Bitcoin. But the funny thing is it is fully EVM compatible layer 2. So if you want to build gaming application, you don't have to wait for volition. You can copy an OP-stack rollup, deploy on Citrea, settle on Citrea, but use Avail or Celestia as your DA layer, and you can build your gaming application. So all the infrastructure built for Ethereum can be run on Citrea easily. You can get share sequencers, you can get L3s, you can get OP-stack chains, you can get Blockstream, you can get VectorX, all the bridges. Just deploy on Citrea and work on your customized chain. So our goal is not introduce our own stack because Bitcoin is extremely unique and the data is quite limited. So you cannot actually build, let's say, thousands of rollups on Bitcoin, right? It will compete with each other. But you can come back with L3s and other infrastructure built on Ethereum, but run them on Citrea so that people can customize their stack, people can customize their application environments and use any other DA layer they want.
Awesome, Orkun. Well, that's all that I've got. Thank you for your time. Rob, do you have anything else?
Yeah, I guess I've just got a couple like somewhat unrelated questions, which is that like you briefly alluded to this, but how much less could we expect transaction fees to be on Citrea than the main chain?
Yeah, as it is state diffs, it really depends on the usage. But we did some research on like the average Bitcoin, the median Bitcoin fee, and the fees of regular Uniswap transaction is somewhere between Ethereum and Ethereum L2s, Ethereum rollups. So it is not as cheap as like Ethereum L2s because Ethereum introduced blobs. Ethereum already has the settlements. So it has rollup centric roadmap. Bitcoin doesn't do anything for rollups. So it is kind of in between them. It is not as expensive as Ethereum, depending on the usage, but it is definitely expensive than Ethereum rollups.
Got it. And is there any data at the moment as far as like, transaction fees per block that we see at the moment before like rollups on Bitcoin? And then how do you expect that to change? Do you expect there to be like 10 times more transaction fees, 100 times more transaction fees per block?
Yeah. So we had this research a while back, and if we do 10 times more TPS than Bitcoin, we only take quarter of the block, which means we can go up to 40 times more TPS than Bitcoin. But if you have multiple rollups, they will clash with each other because they will compete for the limited block space, and it will increase the fees. But in the short term, I don't think there are like other rollups as near production ready as us. Hopefully, we will have a public devnet very, very soon. Maybe once this is released, we will be already live on Bitcoin testnet. And in that time, we will have more concrete data to conduct these analysis and share with the users and researchers.
Nice. Yeah, I was going to say, like, at what point does the band of brothers trying to secure Bitcoin for the long term diminish when you have so many rollups that are now causing the transaction fees to be so high? Like, where does this kind of balance? It's going to be interesting.
Yeah, I think it really depends on the usage. If you have more good applications and more liquidity, why people won't use other rollup for the same transaction fee, so they will come to you. And eventually, the rollup has the most users and the most liquidity will win the Blockspace race, and the other won't be survive. I expect there will be only like 2 or 3 Bitcoin rollups that is actually the actual real rollups that use Bitcoin as a DA layer. But eventually, you can build L3s on Citrea that settles on that uses DA layer of Citrea, of Celestia and Avail, so they can be extremely cheap, and they wouldn't be compete with Bitcoin Blockspace.
Love it, man. Very, very cool vision and absolutely amazing conversation and presentation. Thank you for coming on and chatting with us today, man.
Thank you for hosting me, guys.